Hello and guten Tag, my name is Max, this is Make Modify, and this is the first part of my custom DIY keyboard series. So, as said, this is the first part. I'm not sure, it might be 3 to 4 parts, we will see. In this part we will have a look at the parts I chose for this build, and then we will go into Fusion and on the interwebs, and I will show you how I designed the base plate, and then we will go to CAM, Fusion CAM, and prepare it for milling. The base plate will be milled from 1.5 millimeter FR4 in black. Yeah, and that's it for this first part. To the project in itself, it will be a fully designed by me keyboard. The only thing that I've not come up with is the keyboard layout. The layout will be based on the iris, but I will design the base plate, I will design a case, wrist rests, even a custom cable to connect the two halves, as it will be a split keyboard. And yeah, there will be no PCB. It will be a hand-wired keyboard. I thought about layouting a PCB and making it, but for this project, this is one of a kind, and anyone can replicate it even without a PCB. So yeah, let's head on over to the bench, have a look at the parts, then go to the computer and start this project. So here we are at the bench. What we will need is some key switches. These are Kale box switches, white, clicky. I'm a clicky guy, so yeah, clicky switches. Next we need some keycaps. As this keyboard will be a bit special, we can't use some standard keycaps, so I will use some of these. These are DSA keycaps. Yeah, they are all the same shape all around, and there's no printing on it. We might fix this in a later video, won't promise too much, but yeah, chances are good. And we need a brain for the operation, which will be a Arduino Pro Micro. You could also use a Teensy, but since the keys are not that many, I get away with using a Pro Micro, and the Pro Micro is even a bit cheaper, way cheaper in fact. Yeah, for the base plate that we are gonna start soon, we will need some FR4. Audio issues, okay, once again. We need FR4. This actually is some FR4, but it's not black. I ordered some black one, and this is also too thin. This is a 1 millimeter, I think, but I ordered some 1.5 millimeter FR4. This is the base material for PCBs. So usually there's a copper coating on top, but you can buy it in sheets like this. And yeah, it's easy to mill, and we will use that in black 1.5 millimeter for our base plate, which we will design now on the computer. Let's move over. So here we are at the PC, and this is the keyboard layout editor. Here you can set up your keyboard. There are some instructions. You can choose a preset if you, let's say, we want an Ergodox as a base. Then you have your Ergodox layout, and then you can select a key and change its position, its size, and so on, till you have a keyboard that is to your liking. But I found this one, and this is the Iris keyboard, which my keyboard will be based on. This is a custom link I made. This is a bit modified. The original Iris has one key on this side. So, but other than that, it's pretty much the standard Iris layout. All credits for this layout go to Lewis Ridden, I guess. Sorry for butchering your name. Yeah, and this is basically the layout. I won't change much about this, but yeah, from there we can go to making the base plate. For this, there is the plate and case builder. So if you don't have Fusion or something like that, You can just use this to make your CAD files, I think, but yeah, I will go with the road I know. So first of all, after setting up your keyboard, you can go to raw data. And as you can see, this is all code. You could also lay out your keyboard by writing this code if you are that hardcore, but I am definitely not. Yeah, copy this over, paste it, and then you can choose your key sockets. Since I will use Kales, these are based on the MX layout, but there are also Alps and are compatible for both MX and Alps, which would give you the most possibilities. Yeah. What else? Yeah, I will not use any stabilizers. As you can see at the layout, these are all 1 unit keys, so we won't use stabilizers. And all the other things are nice, but I won't change anything about this. And go to Draw My CAD. Yeah, and this is our layout. From there, we can go and choose our favorite file type. I will download the EPS, I think, since I will edit it with Illustrator, but you can choose whatever you like. You could also use this as your template and go directly to Fusion. But I will take it into Illustrator first and edit it a bit. So here we are in Illustrator. You can also use Inkscape for this, but yeah, I bought Illustrator, so I will use it. First of all, I will get rid of this border, and then I want to get rid of this key, as I want 2 buttons like on this side. So this, and then I take these, transform, mirror, and copy. Sorry for this being German, but yeah, I guess you will see what I do. So yeah, move it a bit up, not too close to the other key, or the keycaps will interfere with each other. So yeah, and I guess, yeah, that will be, yeah, this is the layout I will use. As you can see, it's pretty much the same as it was, but some minor changes. So now I will delete this part and save this as an DXF. So first of all, I want my center point to be in the middle, so I move it roughly there. Yeah, roughly like this, I guess. So now I go to Export, Layout, DXF, Save, and then I have to choose what I want, millimeters or whatever, inches. The only important thing is to choose the same here as you choose in Fusion afterwards. So I will go with millimeter. Okay. And then I go to Fusion and import it. Here we are in Fusion, and now we can go and insert our DXF by going to Insert DXF. Select our plane. I want it on the top plane. Select our sketch. And now you see it zoomed way out, and this is probably way too big. That's because it's still set to inches. So if we now go to millimeters, like we did in Illustrator, and click OK, and now it's in place, and if we click one side, we see it's 14 millimeters, and that is exactly what we want. So now we can go to Edit, and first thing, we can still move all the lines, and we don't want this to happen because this is our layout, that is the way we want it. So I select everything and say Fix. And now you can see the blue lines turn to green, and you can't move these anymore. So now we want our plane, so or plate. So I will go and draw in my rough shape, roughly as I want it to be, and we will go in afterwards and fix it all. So now we have our rough shape for our top plate, and now hit D for dimension, or right click and go to, yeah, or up here go to dimension, but D, you will need it so often, just get used to hitting D. So now I want my border to be 5 millimeters, and this to here. This shall also be 5 millimeters, and I want it all the way around 5 millimeters. So I could make a parameter, which I can change afterwards, and everything would move accordingly. But for this design, it's a bit overkill, I guess. So I will go and just don't type anything, but just click on this measurement, and you will see it got to D1, which is this one. And if you now hit enter, it's 5, and if you change this to, let's say, 3, this will move accordingly. So let's change it back to 5 and just add the other measurements. Also, again, I will just say that's the same. I want this line to be parallel to this line, so select both, say parallel, again D. Now it wants to choose an angle, which is bullshit because it's already parallel, but okay, then I just select this point, double click, again, add the dimension, and go all the way around. This point is now below this, so I will drag it a bit up. Then I go to dimension and also change this to 5 millimeters. And then I want this point to be in the middle of this line on top. So I go to, you can go to line or hit L, click on this point, click, if you move your cursor over this line and you see this triangle, then that means it's the center of this line. Just click there, select this line, and we want it to be vertical. So now I click on it, hit X to make it a construction line. You can also click here or right click and say construction line. But I'm a shortcut junkie, so X. And this will also be 5 millimeters. So this will be our plate design. The only thing left is we want this to be fixed to the shell, to the case. So I want to add some holes for the screws. And you could add them here or wherever you like. For me, I will go to the corners and I will use M3 bolts. So I guess I will go with 3.5 to 4. For a bit of wiggle room, I will go with 4 millimeters. And yeah, I don't want it directly on the corner. That was a dumb idea, I guess. So I will first click here, 4, and then I will make these tangent. Also this and this tangent, and do the same thing for these corners. This not, I guess. And what I always like to do is make some circles first. make them any size you want, select them, and select your precisely dimensioned one and say they are equal. And then they will jump to the right size. And now I have to go tangent, this, and if you select the tool first and then the lines, then it will stay, so you don't have to reselect it and can just go around and add all your restrictions, I guess. Don't know the right word for this, but yeah. And here we are. This will be our plate design. Pretty much done. Now I go to push-pull, and or just hit Q and select this face. And my FR4 fiberglass plate, I want to mill this out, will be 1.5 millimeters. And so here is our top plate. So the only thing left to do is save this, and then I will show you how it's done in CAM. So now that we've saved our piece, we can go to the next step, and that could be for you, maybe you want to export this as a DXF and send it to someone to cut it out for you with a laser or something like that. For me, the next step is CAM, as I want to mill it out myself. I have a little self-built CNC, so yeah. First we go to setup and set up our stock. We have a top offset of 0, so our stock is exactly as thick as this plate. And on the sides I want to go with 3 millimeters for me. Okay. Next, the center point or the origin should be, you can put this anywhere you want, but make sure Z or Z is pointing upwards. If not, as you can see, for me it's always to the top, but the default is under preferences, general. You can set this also to Y up, and Y up is the default, but Z up is, I don't know why Y is the standard, but Z makes totally more sense for CNC and for 3D printing as well. If you don't change this and you model something and you want to 3D print it, you always have to rotate it about 90 degrees, so it's the right way around. So if you set this once, you will never have this problem again. So, okay, here's our stock. I want my point here at the corner. Finding the center point is always a bit, yeah, you could also do it, but I like it in the corner. Maybe because I come from a 3D printing background. So, yeah, we have set everything. Height 1.5 millimeters, that is what my FR4 is. Okay, enough for this setup. And then we want to make our cut. For this one I go with 2D and with 2D contour. 2D contour. Then you select your tool. I select a 1.5 millimeter PCB mill. If it's not in there, you might have to set this up yourself via this new milling tool. Add your dimensions, add your speeds, add your feed grades, and so on. Yeah, here are my settings. That would be a bit too much for this video. So choose your weapon and then go to the next tab where you can set the contour you want to cut. So I choose this one, and the arrow shows you where it will cut. Will it cut on the inside or on the outside? I not always that sure what is the right direction, but I guess we will see when we simulate this. So, okay, our geometry is set for now. Then our height, that all depends pretty much on your setup. For me, I go for a retract height of 0, for a clearance height of 0, retract height of 5. You can also set this a bit lower if you want to speed it up a bit, but let's stay safe, and I go with 5mm. So next, passes. I think I won't change too much here, but on the next tab, what I like really when milling this is the ramp function. And also for PCB milling, I leave out the lead out and the lead in as well. And when I now say OK, I will have a preview. And as you can see, it starts a bit too high. We can go edit. And on this ramping option, the safe distance, we can set this to 0.5, for example. And say OK. Let's have a look. And this is still too high. And also we have no tabs. So first of all, I want to find out where this height is. Ramp clearance heights. Okay, there I will set this to 0.5, I guess. Let's have a preview. Yeah, much better. That goes in way faster. So we don't waste that much time. Next, I want to have some tabs. And for this, I go to, I think here it is. Yeah. And no, it is here. Yeah, here it is. Tabs. And you see here they will go. You can set your settings here. I like these triangle ones. The width for me is okay. The height, I tend to go with 0.5. So they are a bit higher. Yeah, and the tab distance is how many tabs will be in there. If you set this to 6, then there will be some too, but 12 is okay for me. Let's have a preview. And as you can see, we can also simulate this here under simulate, go. And we want to see the stock. And I only want to see the flute or shaft. So, and then we can go play and we see a preview of how it will cut. And there you can also see the tabs. That looks good for me. And now this fits. We can go to edit and select our other contours. So we go here, here. Select all these contours. Oh, not the top one. Go trash. I wish it would do it in the order I clicked it. But till now I have not found a way to set the order in that it should cut. If one of you has any idea, well, you could make a process for each and every single cut, but that is a bit much work for that. So, okay. Now we see how this will work. He goes first to the center, cut that one out, then here, then here, then here, then here, and then around. And yeah, somewhat okay, whatever. It sometimes makes no sense. It would make sense to start here, go there, 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 there. But yeah, I don't know how to set this up. As mentioned, you could make multiple processes and select each single contour for every process, and then you had it. But yeah, then I prefer letting the mill do the work. So Now we have this process set up. We want also to cut out the rest of this, and they are basically the same settings. I will take this process, go to copy or to duplicate. You could also do copy and paste. Edit this one, and on the geometry, clear, and choose this line, and then you have to choose every segment of this line. And as in Fusion, you can also hover over invisible lines, and that way you don't have to turn it every time. If you can get it, yeah. And one more here. Yeah. So now we have that. And as you can see here, the tabs are pretty close, and so I will go with 25. So I have less tabs to cut, and this is only the final contour. The rest is still the same as on the other setting. As you can see, same cutter, same settings. And there we have it. It will cut in there and then go around. Yeah. And one last simulation to check that everything works fine as we want. Go play. Speed this up. So yeah, as you can see, it will mill out all these pieces. Let's skip a bit. And after this is the first process. It will move over to the next process. Let's go there. And then there will be our final contour. And that's basically it. What's left to do is to make the G-code. And this is when you go to post-process. Then you can set where your file shall go. And you have to set your post-processor. As you can see, for me, this is set up to easel F360. It's a Gerbil variant. It works best for my CNC mill, but that might be different for every other mill. So you can give it a name here, or you can say post, and it will ask you what to name it. And then it's done. So here is what this looks like after cutting. It's, as mentioned, black FR4 fiberglass plate, 1.5mm thick. This cut was a mistake from my side. I accidentally pushed a button on the CNC machine and it drove right through. I had to kill the process and restart it, but yeah. Other than that, it got pretty well. You won't see that under the keycaps. Maybe I recut it, but for now this is good enough for me. The switches fit perfectly. Yeah, that's it for this video. In the next part we will go over how to make the case. Yeah, make sure to subscribe, like, share, all that good stuff. Yeah, see you in the next part. Bye.